Hello everyone, I am Mank and welcome to Simplilearn. Today we will take you through a hands-off lab demo of how we can use GAN, Generative Adversarial Network, for the image classification. And for amazing videos like this, subscribe to our YouTube channel and press that bell icon to stay updated. So in today's session, we will discuss what GAN is, and moving ahead we will cover types of models in GAN. And in the end we will do a hands-off lab demo of celebrated face image using GAN. So now let's see what is GAN. So, generative adversarial networks were introduced in 2014 by INJ Goodfellow and co-authors. GANs perform unsupervised learning tasks in machine learning. GANs can be used to generate new examples that plausibly could have been drawn from the original dataset. So, this is an image of GAN. There is a database that has a real 100 rupee note. The generator neural network generates fake 100 rupee note. So, the discriminator network will help to identify the real and the fake note, or the real and the fake images, you can say. So moving ahead, let's see what is generator. So a generator is a GAN neural network that creates fake data to be trained on the discriminator. It learns to generate plausible data. So the generator examples or instances become negative training examples of the discriminator. So as you can see here, the random input generate a new fake image. The main aim of the generator is to make the discriminator classify its output as real. So the part of GAN that trains the generator includes the noisy input vector or generator network, which transform the random input into an instance, or the discriminator network, which classify the generator data. So after seeing what is generator, let's see what is a discriminator. So the discriminator is a neural network that identifies the real data from the fake data created by the generator. So the discriminator training data comes from two sources: the real data instance, such as real pictures of birds, human currency notes, and anything, are used by the discriminator as a positive sample during training. The second one is the fake data instance created by the generator are used as a negative examples during the training process. So discriminator decide from the real images and the fake images generated by generator, and discriminator decide which is fake and which are real. So now let's move on to the programming part and see how we can use GAN using celebrity face image dataset. So before move on to the programming part, let me tell you that the demand for machine learning AI is growing faster than that of other professions. In fact, according to statistics, there will be more than 2.3 million job opening in the field of artificial intelligence and machine learning by 2023. But you can beat the curve with a professional certificate program in AI and machine learning, co-sponsored by Purdue University and IBM. This course covers tools and techniques like NumPy, Pandas, Python, SciPy, along with industry projects like social media by Twitter, delivery service provider by Zomato, and transportation service provided by Uber, and many more amazing projects. Choosing this course can you get hired in renowned companies like Netflix, Amazon, Facebook, and Adobe, and many more, and an average salary hike of 70%. So what are you waiting for? Join the professional certificate program in AI and machine learning and excel your career into machine learning. The link is in the description box below. So here we will start with GAN, Generative Adversarial Networks. Okay, so first I will rename it GAN. Okay, so here we will import some libraries like import OS. So we will do from Pytorch machine learning deep learning library, which work for like neural networks. So here I will like from torch dot utilist dot data import data loader. Okay, so what is this torch dot utilist dot data? So this is an abstract class representing a dataset, and you can custom dataset that inherit dataset and override the dataset. Okay, and this import data loader. So data loader is a client application for the bulk import or export of the data, and we can use it for to insert, update, delete, or export like records. And when importing data, data loader reads, extract, and loads data from the CSV files like comma separated values or from a database connection, you can say. And when exporting data, it's output a CSV file. Okay, then moving forward, like torch vision dot transform as t. Okay, so Transform are like very common image transformation available in the Torch Vision. So transformation module, they can be changed together using compose. So most transform classes have function equivalent functional transform, give fine-grained control over the transformations. And one more, like from Torch Vision dot transforms, sorry, dataset sets import image folder. Okay, invalid syntax. Why it is invalid? I will tell you. It's not, it's import. Okay, yes. So now what I will do, okay, Torch utils it is. Yeah, now it's working fine. So now we will import the dataset. So we are using celebrity face image. Okay, so I will provide you the dataset in the description box below. Don't worry. Okay, so you can download from dataset directly from there. So this is my path to dataset 375 desktop face image dataset. Okay, now let's run it. Okay, now let's run it. Okay, now I guess it's fine. Yeah, so here what I will do, I will set the image size and all. So image size equals to 64, then page size equals to 256, then batch size equals to 256, then stats equals to 0.5 comma 0.5 and again 0.5, okay, comma 0.5 comma 0.5 comma 0.5. Okay, so here we have set the image size and the batch size and the stat values. So now what we will do, we will train the dataset. So here I will write train ts equals to image folder of data directory comma transform equals to t dot compose here I will write t dot resize, then image size, okay, then again t dot center crop, here I will write image size, I will be small, then here I will write t dot to tensor comma t dot normalize stats. Okay, let me do like this. Here I can write train dl equals to data loader, then train ds batch size, then shuffle equals to true, comma num workers equals to 2 number of workers. Then here I will write pin memory. Okay, so true. Let me run it. Okay, error, the system cannot find the path specified. See user. Okay, so there is a path error. Okay, so let me copy my path. Let's see. Now let me run. Yeah, so it's working fine. So let me import torch from torch vision dot utils import make grid. Okay, then import matplotlib dot pyplot as plt, then matplotlib inline. So this torchvision.utils import make grid is used to make a grid. Okay, grid, you know, small boxes, and this matplotlib you already know is used for the making charts, different types of chart, line chart, bar chart, pie chart. Okay, so let me run this. Some spaces. So here I will write now make a function non img tensors, then return img tensors stats 1 0 plus stats 0 and again 0. Okay, so let me run this. Now what we will do, we will make again a new function for show images and show batches. Okay, for that I will write df show image. Okay, then images comma nmax equals to 64 will be there, then figure comma axis equals to plt dot subplots figure size equals to 10 comma 10. Okay, then axis dot set xdix ax dot set vertex. Okay, then ax dot im show, this is image show, then make grid with the non function images dot detect and row. Number of rows will be 8. Then dot permute 1 comma 2 comma 0. Okay, then df show batch dl comma nmax equals to 64. Then for images in DL show images, then images comma max, like nmax, then break. Okay, so now let's see some batches. So I will write show batch train DL. It's loading. Okay, some error. Okay, image. Okay, I'll show the non. Okay, the spelling mistake. So as you can see here, this maybe Robert Downey Jr. This is Robert Downey Jr. This is also Robert Downey Jr. and different celebrities here. So we have to do GAN in this. We will generate the fake images and will generate the new images. Then discriminator will set the images which are real or fake. Okay, so now let's use GPU. Like, let's see GPU is available or not. Okay, so here I will write def get default device, then if torch dot qda dot is available, then return torch dot device, then qda. Okay, else return torch dot device to CPU, then df to device data comma device. Like from this we will move tensor to chosen device. Like, okay, if is instance and see instance data comma list comma double return to device x comma device for x in data, return data dot to device comma non blocking equals to true. Okay, T will be capital here. Then I will write class device data loader. So here what we will do, we will wrap a data loader to move data to a device. So for the df init function to self comma dl comma device. Then here I will write self dot dl equals to dl, then self dot device equals to device. Okay, so here I will write def for the iteration so here I have to give 2 underscore. Here I will write again self, so it yield a batch to data after moving it to a device. So for b in self dot dl, then yield to device, then b comma self dot device. Okay, and the last one is df for the length will write self, then it will return the number of batches. So return length of self dot dl. Okay, invalid syntax. Okay, not dot. Okay, so here I will write device. Here I will write device equals to get fault device device. Okay, then train dl equals to device data loader, and train dl comma device. Okay, so as we already know what is GAN and what is discriminator and generator, so let's take again GAN overview. So a generative adversarial network GAN has two parts. So the generator learns to generate plausible data. The generator instant become negative training examples for producing impossible results. So you have data. So what discriminator will do? So discriminator will decide from the generated data and the real data which are fake and which are real. Okay, this will generator will do. Discriminator, sorry. Okay, so discriminator like takes an image as an input and tries to classify it as real or generated. In this sense, it's like any other neural network. So I will use here CNN, which outputs is a single neural network for every image. So okay, so I hope you know again like what discriminator is, what generator is, and what is like real data. It is this. Okay, and we will generate the data. Okay, fake data. And what discriminator will do? Discriminator will check whether the data is fake or real. Okay, so here I will write import torch dot nn as nn. Here I will write discriminator equals to nn dot sequential okay. So these are some so these are some layer, okay, flattened layer, convoluted layer, okay, leaky ReLU layer. So here I am setting, discriminator like 3 into 64, 64. Okay, so here 64 by 128, 128 by 256. So these are the sizes of the images. Okay, so here discriminator equals to device discriminator comma device. Okay, this okay, what's wrong? The spelling is wrong maybe. Okay, so it's saying discriminator is not defined. Okay, let me debug. Okay, nothing else, the spelling was wrong, so sorry for that. So let me do for the better visuals. Okay, so I hope you know the generator, what generator network is. So here what I will do, I will set the size latent size equals to 128. Okay, so here we have set the discriminator. Now what we will do, we will set the generator. Okay, the sizes like 3 into 64, 64 or 32, 128 and so on for all the layers. So here I am setting for the generator. The same I will write here. Generator equals to device generator comma device. Again the generator is okay. I'm copying this one only. Okay, generator is defined here. Okay, that's working fine. So here, so now what I will do, I will do the discriminator training. Okay, so for that I have to write def train discriminator real images comma opt d. Okay, now we will clear the discriminator gradients. So opt d dot 0 grade. Okay, here we will pass real images through discriminator. Okay, so these are the for the real images, because we have to show the all the real and the fake images, then we'll shuffle, then it will find out which is real and which is not. Okay, so and now we will generate the fake images using latent. Okay, So for that, latent equals to torch dot random input, and the batch size we are giving, the latent size we are giving. Okay, fake images is equal to generator. So now what we will do, we will pass the fake images through discriminator as we did for the real images. Okay, so now we will update discriminator weights. For that, I have to write loss equals to real loss, then plus fake loss. Okay, then loss dot backward opt d dot step return loss dot item comma real score comma fake score. Okay, item. Okay, bracket is missing. Okay, loss backward in 36. Okay, so here what we did we passed the real images to discriminator, then generate fake images, and at the same time we pass the fake images through discriminator, and at the end that loss equals to real loss and the fake loss, we update the discriminator weights. Okay, so now, so this was the discriminator training. Now what we will do the generator training. Okay, so for that I have to write def for that I have to write def train generator then opt g dot 0 grad. So what we are doing here, we are clearing the generator gradients. Before that we did for the same the discriminator one. Okay, so now we will generate the fake images. Okay, what generator do? Generator only generate the fake images. Okay, so from this prediction what we are doing, we are just trying to fool the discriminator. Okay, so here we will update the generator weights. So I will write loss dot backward, then I will write opt underscore g dot step, then I will write return loss dot item. Okay, let's run it. So here I will write from torch vision dot utils import save image, and here I will write sample directory equals to generated. Okay, and os dot make directory sample directory comma exist okay equals to true. Okay, so now what we will do, we will save the sample data. Okay, so I have to create to save samples one function. Okay, so here what I'm doing, I'm making the fake images, generating the fake images and saving it. Okay, so moving forward, well, what I will fix the the latent equals to torch dot random input, then 64 latent size comma 1 comma 1 comma then device equals to device, then again save samples to 0 comma fixed latent okay, save samples is not defined, it's defined here. Yeah, so see, this is the generated images, this is the fake image. Okay, now what I will do the full training loop. For that I have to write from tqdm dot notebook import tqdm, then import torch dot nn dot functional sf. Let me give the spaces. So now what we will do, we will train this we will do the full training loop till the 400 epochs, so it will take a very long time. So first I will write the definition. Okay, I will define one the function. Okay, and then I will get back to you. So yes, so what I did, so this I have set the losses and the scores. Okay, and these are the optimizers, some optimizers, opt you can say optimizer we am creating. And here I am training the discriminator, and here I am training the generator. Okay, for the loss, and here the record of the loss in the scores will the save, and this is for the log of losses and the scores last batch, and for this is for the generated image. Okay, it will save the generated image. Okay, we have already created here, you can say, for the sample image for the saving. Okay, now what I will do, I will write percent time, then lr equals to 0.005, then epochs equals to 400 epochs, means it will take a huge time. So history equals to fit epochs comma lr. Okay, fit is not defined. Okay, I have to run it again. Okay, why it's coming like this? Okay, something error. Item object has 0 grade. Okay, I have to check. So as you can see, it started running. So this box will run till 400. So it will take a long time, very long time. So I will get back to you after that. So as you can see, this is of 1 by 400. So it will run till 339. Okay, so it will take a very, very long time. So it will define the loss of generated, the loss of discriminator, and the real score and the fake score, and at the same time it's saving the generated images. Okay, so it will take a long time and then I will get back to you. So as you can see here, the GANs are done till like 400. Okay, till all the 400. Okay, so now let's do some losses, losses of discriminator and the real score and the fake scores equals to history. So here I will touch dot save the generator dot state underscore directory path comma g dot pth path. Okay, then I will write torch dot save the discriminator dot state directory path comma d dot pth. Okay, some spelling mistake is there. Yeah, so I will write from ipython dot display import image. Okay, so here I will write image, like what the generator generated the image, dot slash generated slash images then 0001 dot png. Okay, let's see. So this is the first image which generated by the generator. Okay, so same we have 400 epochs, so let's see. So here I will check the 100 image. So as you can see, 100 image is more bit clear. So what if I will check for the like 300 image one? It's more bit clear. Okay, now let's check the 400 image. I hope, see, it is clear. So it is, these are the fake images which are generated by the generator to fool the discriminator, to confuse the discriminator. Okay, so now we will plot a graph. We will plot a graph for the epoch and the loss in the for the discriminator and the generator. So for that, right. So as you can see, this is a discriminator, okay, blue one, and there is a generator. So loss for the generator is the more, and the loss for discriminator is less, which is very good. And now let's see the real and fake images. Okay, so these are the real images, score, and these are the fake images. So I hope you understand what is GAN, how to do GAN with Pytorch or Python in ML. So I hope you like this video. Please don't forget to check the course link from the description box below. Okay, and don't forget to subscribe to our YouTube channel. Till then, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.